You know that feeling when you're really in the zone, making progress on a project, things are clicking, and then bam, you just hit some unexpected wall?
Oh, yeah. Happens all the time. Like an API limit, maybe?
Exactly.
Yeah.
That happened to me recently.
Sure.
It was great off. But, it actually got me thinking about the tools I use, specifically Aider for coding with AI. And that led me down this path, really digging into one particular command ask.
It's often those friction points that, well, they make you learn more, don't they?
Hmm.
And Aider, for anyone listening who hasn't bumped into it, it's basically a tool to bring AI into your coding workflow right in the terminal.
Right. And it has these different modes, these commands. We'll probably talk about Architect later, but today, yeah, laser focused on ask.
Because the default, the code mode, it can be a bit eager. You ask it something and might just jump in and start changing your code.
Which is great sometimes, but not always what you want, especially if you're just trying to, understand something first. That's the whole point of ask.
Ask questions, get analysis, but without automatic changes.
Exactly. And I had this embarrassing realization. I'd been writing these super elaborate prompts, basically begging it not to touch anything.
Huh. When you could just use ask all along.
Pretty much. Just ask. Simple.
It really highlights how knowing the core features of your tools is key, doesn't it?
Yeah.
The simplest commands are often, well, the most powerful if you use them right.
So that's our mission for this deep dive then. We're going to walk through what Ask found when I ran it on this project I've mentioned before, heat map cli. Think of it like, listener, you just ran this command yourself.
Okay, let's dive in. What did ask turn up on heatmap Kai?
All right, so I ran ask identify potential issues. And it gave back this numbered list. First up, redundant definitions, specifically the CMPS list.
Ah, the color maps list. And redundant how? Where was it showing up?
It found it in two places, heatmapclient.py and also in heatmapclient.py.
Okay, right away, that's a flag for the DRY principle. Don't repeat yourself. Defining the same constant list in multiple spots. It often suggests the boundaries between modules aren't quite clear yet.
Yeah, it's like if you need to add a new color map, you have to remember to change it in both files. That's just asking for inconsistencies down the road, isn't it? Makes maintenance harder.
Absolutely. So the suggestion would be, what, define it once?
Exactly. Define it once. Aider suggested maybe a config or constants module, or even just keeping it in init.py seems fine for this project size. Then just import it where needed.
Makes perfect sense. Centralize it, make it maintainable. Okay, what was next on the list?
Next was about dependency management. It noticed the project had both a pip file and pipfile.lock, from pipenv, but also dependency stuff inside pyproject.toml.
Okay. Having both pipe and v files and defining dependencies in pyproject.toml, that can definitely cause confusion. Which one is the real source of truth?
Right. Like, which file do you update? Which one do you trust? pyproject.toml is becoming standard for so much now. Configuration, build stuff.
It is, but you really should pick one system for dependencies and stick with it, especially early on. It avoids so many headaches later. Did Aider hint which one seemed primary?
It did, actually. It pointed out that the knoxfile.py, which handles automation like tests and linting it, uses a function called pipeinvinstall.
Ah, okay. That's a strong clue then. It suggests pipenv is probably the intended main tool here.
Yeah. So the recommendation is basically commit to one, clean it up for clarity.
Good advice. Consistency is key with dependencies. All right, moving on.
Next was the use of a multiprocessing logger. It spotted multiprocessing.getLogger being used in a few different files.
Interesting. Now, multiprocessing.getLogger is specifically for when you have, well, multiple processes running, and you need them to log things without stepping on each other's toes.
So Aider was questioning if that was really needed here.
Kind of. It raises the question, is heatmap heavily using multiprocessing for its main job, or is it mostly single process? Because if it's not doing heavy parallel computation, the standard logging.getLogger is usually simpler and perfectly fine.
So it might be adding complexity for no real benefit if the core work isn't parallel.
Potentially, yes. It's about matching the tool's complexity to the actual need. Worth investigating if that extra machinery is pulling its weight.
What else? Configuration consistency, specifically in the knoxfile.py. It noticed different Python versions specified for different Knox sessions.
Ah, like for tests versus building docs.
Exactly. It had like Python 3.8 for docs, 3.9 for dependency stuff, 3.13 for linting and releasing, and then a whole range for the actual tests.
Okay, testing against multiple Python versions is definitely good practice. Ensures compatibility.
But yeah, 8 question needing specific older versions, like 3.8, just for building docs or managing dependencies, unless there's a very specific tool compatibility issue there.
Right. Generally, you'd want those automation environments to align with the Python versions your project actually supports, which you'd usually declare in pyproject.tom or maybe the pip file.
Keep it consistent. And it also made me think, what is the minimum supported Python version for this project? The depth session using 3.9 is another clue, maybe, but it should be clearly stated somewhere.
Spot on. Clarity on supported versions is important.
Yeah.
Okay, what was the next potential issue?
This one sounds a bit more serious. Potential file system interaction risks. In heatmap.py, there's a function refresh output.
Uh-oh. Anything involving deleting files or directories needs care. Does this tie into that purge flag you mentioned?
I think so, yeah. The risk Ader highlighted is, what if the output directory is set incorrectly? Like maybe the user accidentally points it somewhere really high level, like their home directory.
Yikes, and then they run it with purge.
Yeah,
That could be bad, very bad. Data loss potential.
definitely a red flag. Ader did mention the tests seem somewhat aware of this risk, which is good.
Reassuring, but still, that function needs to be absolutely rock solid, lots of checks, maybe even a confirmation prompt before it actually deletes anything, especially with a flag named purge.
Good point. Robustness is key there. Then, still in heatmap.py, it pointed out potential file opening compatibility issues. This was with the open heatmap function.
How it tries to actually display the generated heat map file.
Yeah. The concern is the way it's doing it might rely on commands specific to one operating system. So it works on, say, Linux, but maybe not on Windows or Mac OS.
Ah, the classic cross-platform compatibility problem. What did it suggest?
It recommended using Python's built-in web browser.open.
Makes sense. WebBrowser.open is designed to be more portable. It uses the system's default application for that file type, whatever the OS. Generally a much safer bet for opening files like images or HTML.
Unless maybe you're in a headless environment like on a server with no browser.
True, that's an edge case you might need to handle gracefully. But for typical desktop use, it's usually the way to go. Okay, what about testing? Did it look at the tests?
It did a couple things there. First, it noticed some repetition. A test function called test_debug logs appeared in multiple test files.
Doing the same kind of check in different places.
Seems like it. Ader suggested that if the setup and the actual check for debug logs are basically the same each time, maybe refactor it.
Right, into a shared helper function, or maybe a PyTest fixture that can be reused. Cleans up the test code, makes it easier to maintain if the logging changes.
Exactly. Makes the test suite more DRY, too. Then it raised a really interesting question. Are there any tests that actually check if the generated heat map image is correct?
Ah, not just did it run without errors, or did it create a file, but is the picture itself right?
Precisely. Are we verifying that the visualization actually matches the input data accurately?
That's a much harder testing problem, but crucial for a visualization tool. You might need something like visual regression testing for that, comparing generated images to known good baseline images.
Yeah, that sounds more involved. Finally, Ader listed a few minor points, quick ones.
Okay, like what?
One was slightly ambiguous naming, truncate a rounded count in heatmap.py. It wasn't clear if it rounds first, then truncates, or the other way around.
The order of operations matters. A clearer name like round and truncate or just adding a quick doc string would fix that easily. Readability counts.
For sure. Another tiny one. Using a very specific type hint, pd.core.frame.dataframe.
Instead of just PD data frame.
Yeah. Ader just noted that PD data frame is the standard convention and usually good enough. The super specific one isn't wrong, just less common, maybe a bit noisy.
Fair enough. Stick to conventions unless there's a strong reason not to. Anything else minor?
Last one. In the noxfile.py again, it uses a helper function search amberplace for things like bumping the version number during release.
Okay, custom script for version bumping.
Yeah. Ader suggested looking at dedicated tools for that, like bump2 version or maybe poetry version if using poetry.
Good suggestion. Those tools are built specifically for handling version updates correctly across different files, updating change logs, creating tags. Much more robust than a simple search and replace usually.
Makes sense. So that was the list from Ask. But what's really interesting, and you touched on this, is how Ader does this.
Right. It's not magic. Under the hood, Ask, or Ader's general analysis capability in chat mode, is guided by a system prompt given to the language model.
And we actually found the prompt Ader uses. It's basically, Act as an expert code analyst. Answer questions about the supplied code. Always reply to the user in language. Describe code changes however you like. Don't use search replace blocks.
Exactly. And that last part, don't use search or replace blocks, is key for the ask behavior, telling the AI not to format its response as a proposed code change.
So tools like Ada, they're essentially clever interfaces wrapped around these powerful language models, using specific instructions, these system prompts, to steer the AI's behavior.
Precisely. Understanding that, understanding what's in that prompt, gives you, the user, so much more insight into why the tool responds the way it does and how to get the most out of it.
It's like knowing the recipe instead of just eating the cake. You start to see why it suggests certain things, and it also means you aren't locked into just one tool necessarily.
Spot on. If you understand the kind of prompt that elicits good code analysis, you could potentially get similar results using other LLM interfaces, maybe even interacting directly with a model if you wanted to.
Which really brings us to the importance of, well, prompt writing or prompt engineering. That skill seems increasingly crucial.
Absolutely. Being able to clearly ask for what you need from the LLM, whether through a tools command or a direct prompt, that's how you unlock its real power for tasks like digging into code.
So wrapping this up then, we went through Ader's ask command, used the heat map CLI project as our example, and saw how it quickly surfaced a whole range of potential improvements. Code duplication, dependency tangles, logging choices, safety issues, testing gaps, even minor naming things.
Yeah, it's a really effective way to get a quick, targeted analysis of your code base without getting totally overwhelmed.
Yeah.
Hopefully listeners had a few aha moments seeing how it works.
Right. Getting those useful nuggets without drowning in info. And well, that leaves me with a final thought for everyone listening. We saw how understanding the mechanism behind the tool, like its system prompt, can make you a more effective user.
Where are you going with this?
Well, think about other AI tools you use, maybe not even for coding. What's their underlying logic? What's the secret sauce or the core instruction set? If you could peek behind that curtain, how might it change how you interact with them or what you expect from them? What other black boxes could become clearer if we thought about their fundamental instructions?